Right, good morning, everybody. All right, now we're going to look at homework for section 2 of chapter 15. Let's go ahead and take a look at these. Sketch the described region of integration. Okay, we know the x is from 0 to 7, and the y is from 0 to x, which means since they're equal, it has to be a solid line, not a dotted. So it can't be A. It's a solid line, okay. Now, we want the region, what it is, it's from 0 to 7, and from 0 to x. Well, x is highest, it goes to 7, so it has to be within this bound. That's not it. This goes a little bit too far. This is the wrong direction, so it has to be C. Right, now the next one. Y goes from -2 to 2. And x goes from y squared to 4. So now, because it goes from y squared, so x equals y squared is a graph that looks like this. All right, so it has to have that shape. This one cannot be right. This one cannot be right. So it has to be one of these two. And it goes up to 4. So the highest it goes 4. This one stops at 4. That's good. This one stops at 4. So and we're looking for the bounded region. This goes the wrong direction, so it's got to be C. If you look about that, if y is -2, put that in there. -2 squared is 4. So that's exactly what we have here. When y is 0, x is 0. Right, so it's C. Those are pretty straightforward. Now then, number 3. Okay, this one looks at bounds of integration from vertical and horizontal. So the vertical one, we're looking up and down. All right, so since we're going up and down, we're doing dy dx. Now, for the first bound, we're look at the functions themselves. Since we're doing vertically, we do the highest minus the lowest. So the highest is 1/16, and the lowest is this curve, x to the 4th. And where do we go? We start at 0, and we go to where these two intersect, where y1 equals y2. So we're x to the 4th equals 1/16. So if we take the 4th root of both sides, so the 4th root of 16 is 2. 2 times 2 times 2 times 2. So this bound has to go from 1 to 1/2. And we're doing dy dx. So we're going from 0 to 1/2, x to the 4th 1/16. It's dy dx. Now we're doing horizontally. We're going this way. So this one's going to be dx dy. So this one's going to have to be b. This one's going to have to be b. Okay, let's look at this thing. Oh, I'll do it down here. Since we're going horizontally now, we have to take our two equations and solve for x. So we can't solve this one. It's gone. So right now we have x is equal to get rid of this, we have to do the fourth root. The fourth root of y. All right, so it starts here and it goes to the fourth root of y. Starts at 0, goes to the fourth root of y. Now with respect to y, how far does it go? It goes from 0 to here, which is 1/16. All right, the length of these, in this case, going horizontally, it starts at 0 and it goes up to there, which is what that value is on the x-axis. All right, that's that one. Same thing for number 4. We're doing this vertically. All right, so our function vertically is what? Look, this is where we look at the graph itself. The upper graph minus the lower graph. But remember, let's look at this thing. Y equals 4x. If we take the integration of that, we have the area underneath it. If we take this, how do they define this one? As x squared. And the integration of this one gives you this area. If we take this one minus this one, we're left with the region we're interested in. So we have to take the higher one minus the lower one. And we're doing dy dx since we're doing vertically. So this one's b. The higher one is 4x. The lower one is x squared. Okay, now the horizontal one, that's dy. Now the dx goes from 0 to where these two lines meet. y1 equals y2. So we have 4x equals x squared. We have to solve for x. So x squared minus 4x. Set them both equal to 0. X equals 0. That's what we set. And then x equals 4. That's our upper bound. Or the highest part in the x. All right, now we're going to do it horizontally. We're doing it this way now. So this is y equals x squared, y equals 4x. What we have to do first is, since we're going the other direction, we have to now solve for x now. This one, x becomes y over 4. This one, we square root both sides, so x equals square root of y. And since we're going horizontally, it's the higher one, the furthest to the right, minus this one. So the higher bound will be this one, because that's this one. And this one's going to be dx dy, since we're doing horizontally. So the higher bound is radical y, and the lower bound, take this one minus this one, which is y over 4. Now, it goes from here to here. Remember, it's the same way we had earlier when x equals 4. If x equals 4, then this one equals 16. So those are the bounds of integration. Right? Let's look at number 5. This one is an interesting one. I was looking at it. This one will take us through all the math that we've reviewed. Where's number 5? What did I do with number 5? Oh, is that it? What do I do with it? There it is. Yeah, it's double integral of 6x times sine y dy dx. So it's a double integral from 0 to pi, and then 0 to x, 6x sine y dy dx. All right, now the first part here, it's telling us that we have to integrate with respect to y. So the integral of sine y is negative cosine y. And that's from the bounds 0 to x. But remember, for this one, we have to have only the variables just of x. So that gives us (6x) negative cosine at x minus negative cosine at 0 dx. And this is just the y part. From 0 to pi, we got negative 6 cosine x. Negative and negative is a plus. Distribute in there. Cosine of 0 is 1, so we have 6x. Now this one we could do it in 2 parts. Since it's separated by a plus, we could do negative 6x cosine x dx plus 0 to pi 6x dx. We could do it in 2 parts. All right. this equation, since it has a product, we have to integrate by parts. All right. When you integrate by parts, that's when you take the derivative of one, leave it alone, and take the derivative of the one, leave the other part alone. So the formula is like this. F of x g prime of x equals f of x g of x minus just the opposite of that. F prime of x g of x dx. And moving these things around, we get moving this part to the other side, we get the integral from a to b of f of x g prime of x plus from a to b f prime of x gx dx. All right, so that's the rule we're going to use, where in our function, the negative 6x is our f of x, and the cosine of x is our g of x. All right, so let's look at how that looks. From 0 to pi. Now we're just going to jump straight from here to here. So take the derivative of this first one, which is going to be negative 6 cosine x. Take the derivative of this one, plus take the derivative of this one, leave that one alone. Negative 6x. The derivative of cosine is sine x. This is going to be from 0 to pi. So at pi, we have negative 6 cosine pi minus 6 pi sine pi minus negative 6 cosine of 0 minus 6 times 0 sine of 0. Cosine at pi is negative 1. Sine of pi is 0. Cosine of 0 is 1. That's 0. So negative makes it a positive 6 minus 0. 6 times 1 is 6. So that equals 12. Okay, that's just this part. We now have to do this part. There. Move 0 to pi of 6x dx, which becomes 6x squared over 2 which is 3x squared over 6 squared from 0 to pi. 3 pi squared minus 0. So combining those two, we get our solution 3 pi squared plus 12. And that was number 5. So the answer is 3 pi squared plus 12. Number 6. Okay, number 6 is just asking us to find the integral, the graph of that function, and then integrate it. So looking at this function here, what do we have? We have 2 parts. So we have the first one, y equals x squared, and y equals negative 3x. If we graph both of those, x squared looks like that. Then the bottom one is a downward slope like that. But it goes from 0 to 4, from here to here. This is the area we're looking for. So it's a curve on top, straight on the bottom. That's a curve on top, straight on the bottom. That's the wrong side. That's the wrong side. So it's got to be B. Now we got to find the integration of it. So we got from 0 to 4, negative 3x, x squared, dy, dx. So right now there's a constant, there's a 1 there. So the integral with respect to y of 1 is y, from negative 3x to x squared. Then our dx. We're just doing the middle part now. All right, so we have 0 to 4, y from x squared minus negative 3x dx. Which becomes x squared plus 3x dx. Now we take it with respect to x. So integral of x squared is x cubed over 3. The integral of 3x is 3x squared over 2 from 0 to 4. Let's do 4. So we have 4 to the third over 3, 3, 4 squared over 2 minus 0 over 2, or 3 plus 0 over 2. These are gone. 4 times 4 is 16, times 4 is 64. Three times 16 is 48. Get a common denominator. multiply by 2. So 64 times 2 is 128 over 6. 48 times 3 is 24. 144 over 2, or over 6, I mean. 128 plus 144, 272. We know 2 goes inside both of those, but it ends in an even. So 2 goes into 6 3 times. 2 is 1. 3 with 1 left over. So it's 136 over 3. Right, let's look at number 7 now. Okay, I was looking at this when I printed it out. This one looks the most complex because we have to first draw our picture to see what we're looking at, and then do our integration, because we're looking for the volume under the paraboloid. So let's see what we have here. All right, so number 7, what do they give us? We have the paraboloid, and below the tangent is enclosed by the line y equals x, x equals 0, and x plus y equals 4. All right. The first thing we have to do is draw our picture. To see what we're looking for. X equals 0, the line y equals x, and then since we solve this one for y, and the graph of that one is going to be start at 4, and it's a downward sloping graph, and it crosses the x-axis at 4. Now, what part of the area do we need? Do we need this area, this area? So let's see, we have from 0, when x is 0 is 0. When x is 0, y is 4. When x is 1, y is 1. When x is 1, y is 3. So we're looking for this area. It satisfies our conditions. So the bounds of integration that we're looking at for x squared since I'm going vertically is this. The y's, they go from y equals x, the lower one, to y equals 4 minus x. That's the y function. How about the x? We know it goes at 0, and it stops here. It stops where these two lines meet. So we set them equal to each other. So x equals 4 minus x. Add x to both sides. So x equals 2. So now we have the bounds of integration. So now we start integrating. Let's do with respect to dy. From 0 to 2 with respect to y. So this is two parts. This is a constant in essence. So the integral of that becomes x squared y. This one, add 1 to the top, divide, and now we have to take it with respect to the bounds. That's gonna hurt. Oh well, let's do it. So we first do it to this bound. Anywhere see a y, we put 4 minus x. Then anywhere see y, put an x. All right. Now comes the hard part. Because of this. X squared minus x cubed. All right. I'm going to look at this one on a side note here. That's 4 minus x, 4 minus x, 4 minus x. That becomes 16 minus 8x plus x squared. Sixteen times 4 64 minus 16x minus 32x plus 8x squared, 4x squared minus x cubed. This is just a numerator. So that becomes, combine like terms, we have negative x cubed. 4 plus 8 is 12x squared. Negative 32, negative 16 plus 64. That's the numerator there. Negative x cubed plus 12x squared, 48x plus 64 divided by 3. That's this part. Now here we have x squared times x is x cubed plus x cubed over 3 dx. It's the cleanup time now. We have to clean out all this stuff here. Four x squared but x cubed minus x cubed over 3 plus 4x squared minus 16x plus 64 over 3. We can combine these two. That's minus 4x cubed over 3. I don't want to put 4 there, it's 2. So we have the highest exponent here is x cubed. So it's -1, -4, -5x cubed over 3. 4x squared for us is plus 8x squared. Minus x squared, which is 3 over 3, makes it -8x cubed. Minus 16x plus 64 over 3. All right. Now we gotta do it with respect to x. Yes, I mean, it's not difficult, it's just long. There's just a lot of moving parts here. So the integral of x cubed is x to the 4th over 4. X squared is x cubed over 3. X squared over 2. 64 over 3x from 0 to 2. The 4 cancels with the 8. 2 cancels with the 6. That doesn't go. So we get, so the bottom part's going to be, since they all have x's as 0, we don't have to worry about that. It's 0. So we have -2 over 3, 2 to the 4th, 8 over 3, 2 to the 3rd, 2 squared times 2. Two to the 4th is 16. 16 times 2 -32 over 3. 8 times 8 is 64. Let's go ahead and get different denominators of 3. So that's 24. 2 times 2 squared is 4. 24 times 2. 16. 96. 128 over 3. Oh, this is a minus. Yeah, so we have minus, minus, plus, plus. Just on top, we have 96 plus 32 is 128. That's the negatives. 128 plus 64 is 192. (192) minus 128. 64/3. Again, the hardest part of this is first setting it up, figuring out what area we're integrating. And once we find out what area we're integrating, then the mechanics of it is long and arduous. It's very long and arduous. Where's that question sheet? So the answer is 64/3. And now the last one. Sketch the region of integration of the solid. Yeah, this is not relevant to us. We just want to know the bounds of integration. So we have dy dx. So we know the x goes from 0 to 6. That's what this one tells us. The y's go from 0 to 4 minus 2x over 3. When x is 0, y is 4. And it's a downward slope from there. When x is 1, it's 10/2, shows a downward slope. So that one is, this is wrong. This is the wrong endpoints, wrong graph, so it has to be D. Now, what is it going to look like with our function? Remember, our x and y axis has to have, x has to be 6 and y has to be 4. X has to be 6, y 4. Okay, this one can't be right. This one can't be right. 6 and 4. But this one has area outside of it. So that can't be right. And we know that at the origin, our vertical height, z, is 3. Here's our function. When x is 0 and y is 0, it's equals 3. So it has to be this one. If we had a triple integral, the last one would be from 0 to 3. All right, that's that homework assignment. Hope this helped.